Welcome to the deep dive. We're here to cut through the noise and get straight to the insights from the sources you've shared. Today, we're diving into something really foundational for anyone working in the cloud: AWS route tables and internet gateways. We've got some great material here from AWS Network Essentials, Routes and Gateways Unveiled. And our goal today, to really demystify these core bits of a VPC, a virtual private cloud, and show you exactly why they're, well, non-negotiable for secure connected apps.
Absolutely. And what's so interesting is how these two pieces, often kind of working behind the scenes, are really the unsung heroes of cloud connectivity. For anyone maybe less familiar, you can think of a route table like your VPC's GPS. It's guiding all the traffic, and the internet gateway. That's like the main highway on-ramp.
Yeah.
Connecting your private network to the big, wide internet. They have to work together perfectly to control every bit of data moving around your AWS setup.
Okay, let's unpack this then. Even for people using AWS daily, why are these components, which can sometimes feel a bit basic, why are they so critical?
Right. Well, looking at the bigger picture, they're vital for a few core reasons. First, just basic connectivity. Letting your public subnets actually reach the internet. Think websites, public APIs. Then there's traffic control, making sure data packets only go where you want them to go. That boosts efficiency, avoids mistakes, and super importantly, security. This is how you isolate sensitive stuff, like databases, keep them safe in private subnets away from the public internet. It also helps with scalability, right, as apps grow across subnets. And even compliance. Controlling data flow is often key for things like GDPR. So you can have your web servers out there serving customers, but your back-end database, totally locked down, isolated.
That isolation point is really crucial. So let's get into the mechanics.
Oh.
How exactly does a route table do its job?
Okay, so a route table is essentially just a list of rules. We call them routes. And these rules dictate exactly where network traffic from a subnet should be sent. Each rule has a destination. That might be a specific IP range, or maybe 0.0.00, which is basically anywhere else on the internet, and it has a target, like an internet gateway, or maybe another internal subnet, or even a NAT gateway. A NAT gateway, by the way, is super useful for private instances needing to initiate connections out to the internet, like for updates, without being reachable from the internet. So think of the route table as the traffic cop at every junction in your VPC, telling packets exactly which way to turn. And you'll usually have different route tables for public subnets versus private ones. That's how you control who gets internet access.
Right, directing the internal flow. So how does the internet gateway then provide that bridge to the outside world? Is there anything people often misunderstand about it?
Good question. The Internet Gateway, or IGW, is this virtual component. It's built to be highly available, horizontally scaled. It basically connects your VPC to the public internet. It's like the main gate you mentioned, but a really robust, always open gate for authorized traffic. You attach just one IGW to your whole VPC. Its job is purely to enable that two-way street for internet traffic, a common mistake. Thinking the IGW gives your instances public IPs, it doesn't. It's just a target for routes. It lets resources that already have public IPs, like your EC2 instances, your virtual servers, actually use them to talk to the internet. To make it work, you add a route in your route table, that 0.0.0.0001, usually pointing to the internet gateway. Then you associate that specific route table with your public subnet, and boom, things in that subnet can get online.
Okay, so putting it all together now, route tables directing, internet gateway connecting, how does this create that controlled, secure environment we talked about?
Exactly. The route table makes the decisions. The internet gateway provides the path. This teamwork is what lets you clearly define public versus private subnets. Public subnets get a route table with that route pointing to the internet gateway. They have internet access. Private subnets, their route table deliberately doesn't have that route, so they're isolated. No direct internet path. And when you layer this with other AWS security tools, like security groups acting as instance firewalls, and maybe network ACLs as subnet-level filters, you get this really robust multi-layered defense. You can precisely control traffic flow. It really is the bedrock of a secure VPC design.
It really is fascinating how these quite fundamental pieces, working away quietly, enable everything from just a simple website right up to these huge, complex enterprise systems. They genuinely are the backbone for secure, accessible cloud infrastructure.
Absolutely. And thinking about that control leads to an interesting question for you, our listener. Given how route tables and internet gateways let you segment traffic and direct it so precisely, what specific traffic flow or maybe security weak point in your own cloud environment do you think you could tighten up or optimize using these tools more effectively? Maybe refining some routes or being more deliberate about what goes where. Something to think about.